Hello everybody, hope you had a great snow day, or days. One class before you go back for a 4-day weekend. It's nice. Anyway, today we're going to keep going with inequalities, and we're going to be learning about absolute value inequalities. This is our honors topic, or the bigger honors topic, okay? It's very, very similar to what we did with absolute value equations. So, vocabulary. Remember what absolute value is. Okay, an absolute value is the distance and number? A number. Oh gosh. Come on, Miss Scully. A number is from 0 on a number line. So that's absolute value. We are solving these like we did with the equations for absolute values. We should be getting 2 different inequalities as our answers for absolute value inequalities. Just like with absolute value equations, we got 2 different answers, 2 different solutions. So this will give us 2 different inequalities to represent all different solutions here. And it will result, like, the 2 different inequalities are basically a compound inequality. Okay? So, this is very wordy. Okay? So, just go with me. I feel like this we're also going to have to do a lot of explanation in class. So if you don't get a full understanding of it, full grasp of it, we will go over all of this in class as well. So don't want you to worry too much about it. Alright? So each absolute value inequality represents 2 situations that show the same distance away from 0. The first situation in inequality that is written as what is given without absolute value symbols. Like I said, it's very wordy and very difficult to understand. The second looks like the first with the opposite inequality symbol. Why does this little slidey thing not want to work? And the opposite sign of the number. Okay? So just make sure you have those filled in. If the inequality sign is less than or equal to, the absolute value inequality represents a compound inequality with the word and. Okay? If the inequality sign is greater than or equal to or just greater than, the absolute value inequality represents a compound inequality with the word or. Okay? So remember, with an and statement, those inequalities are connected and form like just 2 dots and like a line in the middle. With the word or, they're going in opposite directions. Okay? So let's look at these and try to rewrite them as compound inequalities. So this is what absolute value inequalities look like. A, we have 8 is, or 8, I can't even speak, guys. I haven't been in school long enough. The absolute value of 8 minus x is less than 2. Okay? So less than means that it's an and statement. Alright? So, the way we write this is we basically just rewrite this whole thing without the absolute value symbol. So, 8 minus x is less than 2, and then we write it again, but we flip the sign and we change this 2 to be a negative. 8 minus x is greater than negative 2. Okay? So you could leave it like that, or you can combine it. Just the 8 minus x is in the middle, and then negative 2 and the 2 are on the outside. You just have the signs correspond. So negative 2 is less than 8 minus x, which is less than 2. Okay? Let's try another one. So we have 1 minus, the absolute value of 1 minus 2a is greater than 11. Greater than means that it's an or statement. Think of it like less than, and greater, or statement. That's a way to remember it. So, since it's a greater than symbol, it's an or statement. So basically, again, I rewrite it the same way. First inequality is just going to be rewritten with the same sign and the same number. I just lose the absolute value symbols. Then I write the word or. I write 1 minus 2a again. Flip a sign so it becomes less than, and make this a negative 11. Okay? So I have the one that looks identical, just minus the absolute value symbols. And then I have the one that loses the absolute value symbols, flips the sign, and changes it to negative. Okay? And then I can go ahead and solve it when they ask me to actually solve it. So you guys are going to try this one on your own. Okay? Just because it has an equal to symbol does not make a difference. It's still either going to be a less than or greater than symbol. That's what you need to focus on for determining what kind of inequality it is. Okay, so try that one on your own. Example 2. This is where you solve it. Okay, so A greater than or equal to means it's an OR statement. So my first inequality is going to be 1 minus 2p is greater than or equal to 9. My second one, I flip the sign to make it less than, and I change 9 to be negative. Okay, now to solve it, I just go ahead and solve these two inequalities. So this first one, I'm going to subtract 1 from both sides. So now I have negative 2p is greater than or equal to 8. Divide everything by negative 2. I get p is less than negative 4. Or, on the other side, I subtract 1 from both sides. Get negative 2p is less than or equal to negative 10. Divide everything by negative 2. Or, p can be greater than or equal to 5. What that means, because they're two separate, what it means is that any of those numbers that satisfy either less than negative 4 or greater than 5, if I plug that in here, the absolute value of it will be greater than or equal to 9. Okay, so it doesn't actually mean that p has to be greater than or equal to 9, but when it goes into this inequality, it will come out true. So you guys are going to try this one on your own. My suggestion might be to flip it around so the inequality comes, or not the inequality, the absolute value comes first. That just might make it a little bit easier for you. You don't have to, but I'm just saying it might be a little easier because our examples have been like that. Okay? Now, question for you. What if you had the absolute value is less than negative 4? Well, the first question should be, can an absolute value be less than a negative? No, it's always going to be positive, right? So because it says it's got to be less than a negative, that's not possible, which means you have no solution. Okay, and you could probably figure that out just by doing it yourself, okay? Like, not even like trying to work it out, because if you tried to do and create a compound inequality, it would still give you two inequalities. However, when you test them, they don't always come out true, so you have to be careful. Now, what if you had something that said this absolute value has to be greater than negative 4? Well, can an absolute value be greater than a negative? Yes. So that means you'd have to solve it and actually figure out what would work. Okay? Sorry, if you hear noises, it's my dog. He's stretching at the moment. It's kind of cute, but it's also kind of annoying. Oh, he's funny. Oh, I forgot I had more. Oh, sorry. There's a few trying runs today, but not too many. So let's go ahead and try these now. We have to solve and graph the following inequalities. Okay? So, I just had one big number line to put all my work in. So, A and B I'm going to do, but you guys are going to do C on your own. Okay? So, A, it's a less than statement. So that means it's an and statement. So I'm going to go ahead and rewrite it so it has the and statement in between. So that means I'm going to have 8 minus 3m less than or equal to 13, and 8 minus 3m is greater than or equal to negative 13, which I just wrote as one big thing. Okay? You guys can use the word and, you'll come out with the same thing. Now, I just wanted to show you how to do it when it's still combined, rather than you guys separating it. You can go ahead and solve this while it's still combined. It just means that when you subtract 8 from the middle, you have to do it to both on either side of it as well. So you'll be subtracting 8 from 3 places. So now you have negative 21 is supposed to be less than or equal to negative 3m, which is less than or equal to 5. I divide everything by 3. Remember, when you're dividing by a negative number, you have to flip your sign. So it becomes 7 is greater than or equal to m, which is greater than or equal to negative 5/3. Okay? So to go ahead and do that, 7 is right here, and it's a closed circle. 5/3, negative 5/3 is around close to 2, so I put it right there. And it's an and statement, so I connect them. Okay? B, I have a greater symbol, so that means it's or, so I have 4r minus, did I do this? No, I did it as one line. 4r minus 4 is greater than 40, or 4r minus 4 is less than negative 40. So then I go ahead and add 4 to everything, basically. I get 4r is greater than 44, or 4r is less than negative 36. Divide everything by 4 now. I get r is greater than 11, or r is less than negative 9. So because or, I should have two separate inequalities. So at 11, I should have an open circle pointing to everything bigger, and at negative 9, I also have an open circle pointing to everything smaller. Okay, so you guys are going to do C on your own. I think I gave you a hint because I told you it's an or statement. Okay, so give that one a try. This is the last example? Yeah. Alright, last example. So we have to solve and graph this one as well. Now, in order to do these kind of things, just like with equations, the absolute value needs to be by itself. So we have to isolate the absolute value before we split it into an and or statement. So to do that, I'm going to get the absolute value by itself. I'm going to subtract 5 from both sides. So then I get 3 times the absolute value of 2x minus 1 is less than 9. Divide everything by 3. So now I have the absolute value of 2x minus 1 is less than 3. That's when I can split it. So it's less than, so it's an and statement. So I should have 2x minus 1 is less than 3, and 2x minus 1 is greater than negative 3. Okay? Then I can go ahead and solve it. So I'm going to add 1 to both sides, or all sides really. So I'll get 2x is less than 4 over here, and 2x is greater than negative 2. Divide everything by negative 2, or divide everything by 2 at least. So then I get x is less than 2 and x is greater than negative 1. To graph it, here's my number line. At 2, I should have an open circle. Oh, no, not that one. Oh no! I showed you the wrong one. Delete. At 2, I have an open circle, and at negative 1, I have an open circle, and then I connect them. Okay? And so you guys are going to try this last one on your own, which has less to get by itself. You have less steps to get it by itself, so that should be a little bit easier. But go ahead and try these on your own. I'll answer any questions we have on it next class. And yeah, that's about it. Oh, you do have a quiz on 1 and 2 step next class. Okay? So, I will see you then. Goodbye.